start with this equivalent resistance calculation. What we find in this that this is the paths available, one, this is also one, and this is also one. We can say that this is one path, this is also one path, this is also one path. So now three parallel paths are there. So we should always start the equivalent resistance starting from the last end, because I want to find what is my equivalent resistance here. So let us start from the last end, rear ends, because these three are not interfaced. We can just remove these three and convert into a single resistor. So what we will do, we will just take this once more. Yeah. Now in this picture, we will remove these three and we will redraw this with a single resistor like this. The resistance of this is 3 ohms. Next, we can see that if we will consider these two, like this is one, another path is like this. So these two are in parallel. If, from here there is a current is distributed, no? So that's why these two are in parallel. So we can convert these two into a single resistor. So we know that 1 by R equivalent is equals to 1 by R1 plus 1 by R2. If we take LCM, it is R1 R2, upper is R1 plus R2. So this is the output of this one. So we can write R equivalent is equals to R1 R2 by R1 plus R2. Correct? So we can write here that these two can be converted into a single resistor, and we can write R equivalent that is equal to 2 into 3 by 2 plus 3, that is 6 by 5 ohms. So what we were going to do, 6 by 5 we will write, and removing these two. So we will write it, and this is nothing but 6 by 5 ohms, or 6 by 5. It is understood the unit is ohm. Again, now we can see that these three are in series. If these three are in series, we have to add them. So let me just redraw once more. And paste it over here. Now if these three are in series, what we will do, we will remove these three. And instead of that, we will place one resistor over here. So what is this resistance? This will be 6 by 5 plus 2 plus 2, or I can write 6 by 5 plus 4. So that will be equals to 26 by 5. So I can write here 26 by 5. Now you would have understood what we are going to do. So these two are in parallel, and together they are in series with this. We are going to combine these two are parallel. So what we can do is, we can write 2 into 26 by 5 by 2 plus 26 by 5. This is nothing but 2 into 26 by 10 plus 26. That is 2 into 26 by 36. This is 18, and we can get 9, and this is 13. So we get 13 by 9. So what we can do, remove these two things and add a resistor saying that this is 13 by 9. So finally, these three resistors are in series. So we just need to add all these three resistance and write down here 13 by 9 plus 2 plus 2, 4. And that will be equals to 13 plus 36 by 9, that is 49 by 9 ohms. So what is the value of R equivalent is equals to 49 by 9 ohms is the answer. Correct? So this we can solve this like this. Next, we have got another problem like this here. So in this problem, in order to create a confusion, there's a line this is shorted over here. And we can consider this entire thing as a single node. For that, we can assume that this wire is connected like this and taken like this. That is fine, because through this way also they are connected. And this is one circuit over here, and this is another circuit over here, and there are two circuits, and this one is in parallel with this one is in parallel with this. We can redraw and take it all those things. So let me just take it once more, this thing, and put it over here. Okay, so what I'm going to do, I'm going to remove this side and redraw the same circuit, saying that this is connected over here, this is connected over here, and this side I can, yep, sorry, is like this. Okay, so what we can do is that these two are in series, similarly these two are in series, so 2 plus 2 is 4, here also 2 plus 2 is 4. So what we can do is we can remove this side and replace it by a resistance. We can replace it by a resistance of 4 ohm. This side also we can remove and replace it by a resistance of 4 ohm. Now these two are in, how do you say, because we want to find RAB. What this is the path, right? It is like this, and there is another path is like this. So when I'm moving in this path, so these two are in parallel, right? So we can go in this way, also in going this way. So these two are in parallel, so join them. So 4 and 4 in parallel, so that becomes 2 ohms. And here also 4 in 4 in parallel, that becomes 2 ohms. Now you have got these three are in series, and here also you have got these three are in series. So just combine those three and you can write 2 plus 2 plus 2, that is equals to here 6. Similarly this side also 2 plus 2 plus 2, that combines to give 6. Now these 6 and 6 are in parallel. We can see it. If suppose instead of A and B like this, we can stretch this A and B over here. Now it is very clear. We can see that like these two are the two different parallel paths, and they are in parallel. So we can find and say that RAB is equals to 6 and 6 in parallel. Obviously this is 6 into 6 by 6 plus 6, 12. This is 3. So directly you can write 6 and 6 in parallel. The answer is 3 ohms. Correct? Next we have a problem like this, and here you have got lot of short circuits over here. See, so where is AB? AB is mentioned over here. So what are the parallel paths? This is the parallel paths over here. We can move in this way and also in this way. We can move in this way, and since this is a path like this, so I'm not going to flow over this. The current will not going to flow, because once, see, if this current is going like this, it can directly go up to here and come to B. Another option is you can go here, come this and here. Another option is you can go here, come this and come here. But no way it is going to this 2 ohm resistor. Similarly, the current can go here and come here and reach here. It can go here, come here and reach here. So this 2 ohm is out. So let us remove it. Okay, rest of the is there. So in order to simplify the circuit look, so what we can do is we can simply remove this and redraw this. Okay, because if it is connected in this way, it's same as connected in this way. Okay, now you have got the flow of current in this. Okay, you need to go to B. From A to B you need to go like this, and here you reach B. Also you can go from A this way, you can come to B. Now these two options, out of these two options, why a current will go from 2 ohm when this 2 ohm is short circuited? So that means this doesn't have any use because the current is going via this. So that's why we can remove this one also from the circuit. Now the current can go from here, it can reach out to this. So this 2 ohm is also short circuited. See, if it will go from this 2 ohm and it will reach here, fine. But this 2 ohm is getting short circuited from this 2 wire. So this way I am going to remove this also. Okay. So I have got one option like this, another option over here, third option like this. So out of these two are in parallel, confirm. What we can do is remove this, and I can redraw that this is connected over here. Also we can remove this, say that this is connected over here. So these two are in parallel. I can say that together they are parallel, means 2 and 2 parallel, the 1 ohm. So I will remove these two and I will say that okay, this is 1 ohm resistor. Now the one side we have got 1 plus 2, we have got 3 ohms, the other side we have got 2 ohms. So I can redraw that, saying that okay, I have got one side is 2 ohm, the other side is 3 ohms. So together the equivalent resistance is 2 into 3 by 2 plus 3, that is 6 by 5 ohms. So RAV is equal to 6 by 5 ohms.